All right, this is 8285 review. Yep. All right, so number 1 and 2 here, they just want you to find the value of each trigonometric ratio. So for sine of C, so this is the angle we're looking at. The hypotenuse here is 26. Across from the C is opposite, so opposite is 24. Next to the C is adjacent, so 10 is adjacent. So sine of C is going to be opposite over hypotenuse. That's 24 over 26. We can reduce that to 12 over 13 if we want. If we wanted simplest fraction. Okay. Cosine of C, so here's C. Label our hypotenuse is 29. Across from C is the 20, so that's opposite. Okay, next to is 21, so that's our adjacent. Right, cosine is adjacent over hypotenuse, so adjacent is 21, hypotenuse is 29, 21 over 29, right? Adjacent over hypotenuse. Right, if we need the SOHCAHTOA mnemonic over here. SOHCAHTOA. Right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, the next set here. Find the trig ratio to the nearest tenths place. 10,000ths place, right? So that's going to be 5 decimal places. It's going to be 4 decimal places. Right, thousandths place would be 3 decimal places, so 10,000ths is 4 decimal places. So I'm just putting this into my calculator. I'm going to click cosine and then type in 18 and hit enter. I'm going to make sure I'm in degrees, and that's going to be 0.9, so 0, 0.951, 0, and then the 5 rounds up to a 6. Right. Then sine of 79, I'm also just going to put that into my calculator. So sine of 79 is 0.98162. 0.98162. Okay. For 5 and 6, we want to find the measure of the degree. So on the sine, cosine, and tangent functions, we input the angle measure, and the output is the ratio. So we need to use the inverse sine function, right? And for the inverse sine function, we're going to input the ratio, 0.1564. I'm sorry, we said 4 decimal places here. So this should be 1. And this should be 0.9816. There we go. Okay, so we're going to input the ratio into the inverse sine function, and the output is going to be our angle measure, which is W. So now I'm going to put this in my calculator. Inverse sine 0.1546. I'm going to enter, and then it's going to give me an output of 8.8936, but we want to round to the nearest degree. So that's going to be 9 degrees. So W equals 9 degrees. All right, over here we have tangent of B equals 1.0355. So our input is angle B, the measure of angle B. The output is the ratio. So to find the angle, we need to input the ratio into the inverse tan function. So we're going to input the ratio 1.0355. And the output is going to be angle B, right? The measure of the angle. So then we'll go to my calculator. I'm going to type in inverse tangent, 1.0355. I'm going to hit enter. And that's going to be 46 degrees. Rounded to the nearest degree is 46 degrees. The measure of angle B there is 46 degrees. All right, next one. Find the missing side, round to the nearest tenths place, that's 1 decimal. So what we're going to do here is we're going to label. So here's our hypotenuse. This is the angle we're going to use. So 26 is next to, so it's adjacent. Okay, so we have adjacent and hypotenuse. So remember, if we have SOHCAHTOA, right, we're using cosine because we have adjacent and hypotenuse. So I'm going to use cosine. So I'm going to say cosine. I'm going to input the 56 into my function. And my output is going to be adjacent over hypotenuse, so 26 over x. Right, we're using regular cosine because we're solving for a side. When you're solving for a side, you use regular. When you're solving for an angle, you use inverse. Right, so now we need to solve for x. So we need to get x out of the denominator. So we're going to multiply both sides by x. Cancels. So I have x cosine 56 equals 26. And now I need to divide both sides by the cosine of 56. Cosine 56, right? If you divide on one side, you got to divide on the other. That is the division property of equality. So then we get x equals 26 divided by cosine 56. And I put that in my calculator now. 21 divided by cosine 56. And I get 37.6 as my answer. Yep. 37.6 units. And I check and see if that answer makes sense. I think that answer does make a lot of sense. It's got to be bigger than 26 because the hypotenuse is the biggest side, but it's also not ridiculously big or ridiculously small, right? So I think that looks like it probably should be a pretty good answer. All right, number 8, same thing. Label the hypotenuse first. Circle the angle we're going to use. Right, and then x is across from the 51, so it's opposite. So we have opposite and hypotenuse. That's going to be sine, right? Opposite and hypotenuse is sine. So we're going to use regular sine because we're solving for a side. So I'm going to input the angle measure into my sine function. So sine 51. My output is the ratio of opposite over hypotenuse, so x over 25. Okay, I'm going to multiply both sides by, 25. That cancels on that side. So now I have 25 times the sine of 51 equals x. I just type that in my calculator and I get my answer. 25 times sine 51, 19.4. Round to the nearest tenths place, that's 1 decimal. So 19.4 units. And that makes sense. It's a little bit smaller than 25. So that seems like a reasonable answer there. All right. Let's put SOHCAHTOA back up. So now we're solving for the measure of the indicated angle. So when you're solving for an angle, we need to use the inverse function because we need to input the ratio so that we get the output as our angle. So on this one here, let's label. So 15 is our hypotenuse. We're going to solve for this angle here. So across is opposite. So 11 is opposite. So we have opposite and hypotenuse. That's going to be sine. And again, we're using inverse sine because we're solving for an angle. So we're going to input the ratio of 11 over 15, opposite over hypotenuse, into my inverse sine function, and that's going to give me my angle measure, the question mark over there. So what I'm going to do here is I'm going to hit trig, go down to sine inverse, the one with the -1. right? There really isn't a -1. It's just a symbol for inverse. And then I'm gonna put my ratio in and I get 47 degrees. So I input the ratio into the inverse sine function. The output is 47 degrees. This angle here is 47 degrees. All right, the next one, my hypotenuse is the blank side, so that's the one I'm not going to use. 28 is opposite, 15 is adjacent. So I'm going to use the 28 and the 15, the opposite and adjacent. That means I'm going to use tangent. And again, I'm solving for an angle, so I'm going to use inverse tangent. I'm going to input my ratio of 28 over 15, opposite over adjacent, into my inverse tangent function. And the output, when I hit enter, is going to be my angle measure, 62 degrees. Or rounding to the nearest degree, so it's 62 degrees. All right. Number 11, we need to use special right triangles. So let me draw a 30, 60, 90 over here. 30. Format, we definitely want smaller. So that'll be 30. So that's fine. And then this one right here is 60. I probably should have just written them. Here's my right angle. If we make this side 1, this is the short leg. So short leg times 2 is going to be the hypotenuse. And then the long leg is the short leg times the square root of 3. So 1 times the square root of 3 is 3. All right, and then we need our 45, 45, 90. So 45, 45. Right, if we make the leg 1, the other leg is also 1. And then the hypotenuse is the square root of 2 times the leg. So 1 times the square root of 2 is square root of 2. Now that we have our special right triangles, we can start filling these in. All right. Sine of 30. So here's 30. Opposite. Let me put Toa up there. Okay. Sine is opposite over hypotenuse. So opposite of 30 is 1. Hypotenuse is 2. Okay, sine 45. Opposite, doesn't matter which 45 you use, it's going to be the same. Opposite of 45 is 1. Hypotenuse is square root of 2. Okay, the problem with this is we don't want the radical in the denominator, so we need to multiply by square root of 2 over square root of 2. And that's going to give us square root of 2 over 2. All right, sine of 60. So sine of 60, opposite is square root of 3. Hypotenuse is 2. So square root of 3 over 2. All right, let's do cosine. Okay, cosine is adjacent over hypotenuse. So adjacent to 30 is square root of 3. Hypotenuse is 2. So square root of 3 over 2. Cosine 45. So adjacent to 45 is 1. Hypotenuse is square root of 2. So again, we need to rationalize our denominator. So we need to multiply by square root of 2 over square root of 2. 1 times square root of 2 is the square root of 2 over 2. And then cosine of 60. So adjacent to 60 is 1. Hypotenuse is 2. That should be 1 over 2. Tangent. Opposite over adjacent. So tangent of 30. Opposite is 1. Adjacent is square root of 3. Right? We don't want that radical in the denominator, so we need to rationalize the denominator by multiplying by square root of 3 over square root of 3. That gives me square root of 3 over 3, right? 1 times the square root of 3, and then square root of 3 times square root of 3 is 3. Tangent of 45, so opposite is 1, adjacent is 1. That's 1 over 1, which is simply 1. And then tangent of 60, opposite is square root of 3, adjacent is 1. Square root of 3 over 1 is just simply square root of 3. And those are your ratios. All right, 12 and 13. So let's start with 12. So we need a diagram here. So a building is 50 feet high. At a distance away from the building, an observer notices that the angle of elevation to the top of the building is 41 degrees. So we have 50 feet tall is our building, right? Let me put our building in, right? This is our building. Okay, and then somewhere on the ground, right, some distance away, you have a person down here who is looking upwards, right, to the top of the building. And they're saying that angle of elevation is 41 degrees. We want to know how far the building is from, how far the observer is from the base of the building. So here's the observer, and here's the base of the building. So we're looking for the bottom here, which is X, right? This is the observer, right? Right here. If I could draw an arrow, good. Right? This is the observer. And then this is the bottom of the building, the base of the building. All right, so what we're doing here is we're just simply trying to find X here. So we're finding a side, so we're going to use regular trig. So again, let's bring up our TOA. All right, and let's label. This is the angle we're using. 50 is opposite, X is adjacent. So opposite and adjacent is going to be tangent. So we're going to do tangent. We're going to input the angle measure, 41, equals opposite, which is 50, over adjacent, which is X. And then we can solve for X. So we need to multiply both sides by X. Whatever's in the denominator is what you're multiplying by. So this is X tangent 41 equals 50. And then we divide both sides by tangent 41. And there we go. X equals, we're going to do 50 divided by tangent 41. Gives me 57.5 feet. Okay. That's a 41 right there. All right, next one here. A bird sits atop a lamppost. So we're going to have a lamppost. Let me do a different color. Do a purple lamppost. So here's a lamppost. It's a little skinny. There's my lamppost. The angle of depression. So right, that angle of depression is the angle looking down, right? So if that's our horizontal, the angle of depression is the angle looking down. The angle of depression is 40 degrees. Right? Towards an observer, right? So the bird, this is the bird up here, right? So this is where the bird is. And then down here is your observer. Right? So the bird is looking down to the observer. Right? Right? What else does it say? So it says 40 degrees, right? So alternate interior angles. If this is 40 degrees there, this angle down here is also going to be 40 degrees because those are alternate interior. And the horizontal is going to be parallel to the ground. Then the distance from the bird to the observer, so the distance from the bird to the observer is 25 meters. How tall is the lamppost? Okay. So again, we're going to do regular trig because we're solving for a side. So if I label my sides, this is my opposite. 25 is my hypotenuse. So I'm going to use sine. So I'm going to say sine of 40 equals opposite, which is x, over my hypotenuse, which is 25. And I'm going to multiply both sides by whatever's in the denominator. And this time it's 25. So I'll multiply both sides by 25. So I get x on the right side. And on this side, I got 25 times sine 40, which gives me 16.1 meters. Right? 16.1 meters. Okay. That's the angle of elevation at the bottom, going up, the angle going up, angle of depression, the one below the horizontal. All right, next two here, find the perimeter and area. So we need to find the sides of these triangles. So let's start with the first one here. Okay, I'm going to call this X. I'm going to call this Y. All right, I'm going to find X first here. So this is 54. That means this is opposite. This is adjacent. And then, I'm sorry, this is the hypotenuse, right? It's across from the right angle, right? That's a right angle. This is a right angle. And then this is my adjacent. So I probably should have used a different color for those. So this is hypotenuse. This is opposite. This is adjacent, right? So if I'm solving for x up here, I'm going to use opposite and hypotenuse. So that's going to be sine. So I'm going to do sine of 54 equals opposite, which is 41, over x. Right? I'm going to multiply both sides by x. So I get x sine 54 equals 41. And I'm going to divide both sides by sine of 54. It's going to cancel. So then I get x equals, right? And now I have to do 41 divided by sine 54. That's 50.7 units. All right, now for y, now I need to do the height there. So for this one, I'm going to do adjacent and opposite. So I'm going to do tangent. So tangent 54 equals opposite, which is 41, over adjacent, which is the y there, which is y. We can just call it y. So now I'm going to multiply y on both sides. So I get y times tangent 54 equals 41. And now I can divide both sides by tangent 54. Okay. So 41, that's going to be 29.8. Okay. So let me fill in my diagram here. So my x was 50.7. And then the height here, this height was 29.8. Right now we're going to look at the second triangle. So we're going to look at the second triangle now. We're going to have to do two more as well. So we know the height here, this is adjacent. Okay, let's find our opposite first. Okay, so we know that's opposite and adjacent. That's going to be tangent. So tangent of 68 equals opposite, which is x, over 29.8. Right, then I can multiply both sides by 29.8. Is cancel. So then I can do 29.8 times tangent 68. I get 73.8 equals x, right? I got 73.8. Now for this triangle, if I call this y, I have adjacent and hypotenuse, so I'm going to use cosine. So I'm going to input the 68 into my function. Okay, adjacent is 29.8 over y. So I'm going to multiply y on both sides, and then I'm going to divide by cosine 68, right? So I'm going to end up with y equals 29.8 divided by cosine 68, right? So 29 divided by cosine 68. So that's 79.6. Right? So now I have this side as well is 79.6. All right, and then it says perimeter and area. So perimeter, we're going to add up all the sides. So 50.7 plus 41 plus 73.8 plus 79.6 gives me a perimeter of 245.1. Okay, and then area is 1/2 of base times height. So the base of this, right, is going to be 41 plus 73.8. 41 plus 73.8, which is 114.8. You had to add those two on the bottom together, and then your height is 29.8. And we're going to multiply these. So 1/2 times 114.8 times 29.8 gives me 1710.5. 1,710.5. And again, that would be units squared. Perimeter is just in units. All right. The next one, I'm just going to find the sides real quick here. I'm not going to write the equations out and solve them all. So I'm going to clear this and let's look at the next one. All right, so this one, let's start with this triangle. We have 34. This is adjacent. Let's find x and y. So for x, we're going to use cosine, right? So we're going to do cosine 34 is going to equal 17 over x. Right, so we then need to multiply x on both sides and divide by cosine 34. So you're going to end up with 17 divided by cosine 34, which is going to be 20.5. So this side here is going to be 20.5. If I'm doing y, I'm going to use tangent. So I'm going to say tangent 34 equals y opposite over 17, right? The adjacent opposite over adjacent. On this one, I would multiply 17 on both sides. So 17 tangent 34 is 11.5. So the middle one here is 11.5. Okay. For the next triangle, let's call this W and Z. We'll call this W and this Z. So I'm gonna find W first. So I have opposite and adjacent. So I'm gonna use tangent 41. Opposite is W. Adjacent is 11.5. So I'm going to multiply 11.5 on both sides. So this is going to be 11.5 times tangent 41, which is going to be 10.0. 10.0. All right, and then Z, I'm going to use the 11.5. That's adjacent and hypotenuse. So I'm going to use cosine. So cosine of 41 is going to equal 11.5 over Z. We're going to multiply Z on both sides and then divide both sides by cosine 41. So this one's going to be 11.5 divided by cosine 41. This is 15.2. And now that we have all our sides, we can find perimeter by adding up the outside. Right, so we're going to do 15.2 plus 10 plus 17 plus 20.5. 15.2 plus 10 plus 17 plus 20.5 gives me 62.7 units. All right, and then area is 1/2 base times height. So that's going to be 1/2. The base is 10 plus 17, which is 27. And then my height is 11.5. I can put that all in my calculator, 1/2 times 27 times 11.5. That's 155.3. 155.3 units squared. All right, last one. All right. So what we want to do first is we want to find the height. I'm going to call the height here H. Okay. So let me draw the big triangle separately. So this is the big triangle. I'm going to draw it in purple here. So we'll call this H the height. This is 35. Okay, and then the angle we're using is 23 degrees. All right, so to find the height, opposite over hypotenuse, right? That's going to be sine. So we're going to do the sine of 23. Whoops. Equals H over 35. Okay, we're going to solve this by multiplying both sides by 35. So it's 35 times the sine of 23. I get 13.7 for my height. So this is 13.7. Okay, and then I'm going to find my adjacent here, which is y plus z. We can call it, x maybe. Okay, that's the whole base. So I'm going to use cosine. So cosine 23. Adjacent is x. Hypotenuse is 35. Okay, I'm going to multiply both sides by 35. So it's 35 cosine 23. Gives me 32.2 as my base. Equals x. All right. So this base is 32.2. So that means the whole bottom, this whole thing, is 32.2. I'm not going to write it in yet. All right. And then now let's look at the small triangle. So that's this one. We said we know the height is 13.7. Okay. And we know we have 54 and we're solving for y here. So we're using opposite And adjacent, that's going to be tangent. So tangent of 54 this time is going to equal opposite, which is 13.7, over adjacent, which is y. And then we got to multiply y on both sides and divide by tangent 54 on both sides. So we end up with 13.7 divided by tangent 54. 9, so this will be 10.0 equals y. Okay. And now if the whole bottom, the bottom of the whole thing, right, was 32 point, let's change it back to purple, right, 32.2. Right, we can find z by doing 32.2 minus 10 gives us 22.2. So now we know z here is going to equal 32.2 minus 10, which is going to be 22.2. Okay. So 10 and 22.2. So the big thing here is you want to find the height so you can find y, right? So you got to use the big triangle to find the height. That way you can use that same height for the smaller triangle. Okay.